At 34,500 feet over the Atlantic, the second engine stopped. The nearest runway was 65 nautical miles away. The Airbus now had no thrust, limited electrical power, and 306 people on board. 19 minutes later, it would touch down on an island runway. Everyone survived. This was not one sudden failure. It was a chain, a maintenance mismatch, a hidden fuel leak, and a cockpit response that fed the leak from the only tank still holding fuel. Less than a week earlier, the airline had replaced the right engine. The replacement arrived in an unexpected, older configuration. During installation, a newer hydraulic pump and fuel tube were paired with an older hydraulic tube. The parts did not fit naturally. The relevant service bulletin could not be opened because of a computer network problem, so verbal advice replaced the document. Clearance was forced into the installation. Once pressurized, the hydraulic line moved back toward its natural position, rubbed against the fuel tube, and eventually fractured it through vibration and fatigue. The leak began at 4:38, but the first clear cockpit cue arrived almost an hour later as a fuel imbalance advisory. The crew opened the crossfeed and used fuel from the left tanks to feed the right engine. That action made sense for an imbalance. For a leak near the right engine, it created a path from the healthy side straight to the rupture. By the time the diversion began, more than 9 tons had vanished. The loss rate looked so extreme that the pilots suspected a computer fault, and darkness hid any visible stream outside. At 6:13, the right engine flamed out. The aircraft was still at flight level 390, 150 miles from Lajes. 13 minutes later, at 34,500 feet and 65 nautical miles from the airport, the left engine stopped too. Cabin lighting fluctuated. Oxygen masks deployed after pressurization was lost. The crew completed the all engines out procedure while the cabin prepared for a possible ditching. For the next 19 minutes, the widebody was no longer a powered airliner. It was a glider over the Atlantic at night. Air traffic control gave radar vectors and flashed the runway lights. The Airbus reached a point 8 miles from runway 33 at roughly 13,000 feet, far too high for a normal approach. The captain made a full turn, then S-turns on final, trading altitude for distance. The jet crossed the threshold at about 200 knots, hit hard, bounced, and touched down again. Maximum braking locked and destroyed the main tires. Small wheel fires followed. 18 people were injured during the evacuation, but every one of the 306 people aboard survived. Investigators traced the exhaustion to 2 connected mistakes. On the ground, incompatible tube configurations were installed without the service bulletin that should have prevented the mismatch. In the air, a leak was treated as an imbalance, so crossfeed exposed the remaining fuel to the failed side. The operating lesson is larger than aviation. Never optimize the distribution of a resource before confirming the total still exists. A balanced display can look healthier while the system is emptying. Reconcile fuel on board plus fuel used against the starting quantity. If the total is missing, find the leak before moving anything.